All right, guys, so imagine you have a problem, and the problem is you have a big group of friends that all need to split up in separate cars so that you can go on a long distance road trip. And so in doing so, in organizing these friends in the separate cars, you want to make sure that they have similar interests. And the main topic is going to be your spirit animal. But you want people in the car that have similar spirit animals so that they can get along and get through the ride together without being mad at each other. So that's the problem we're going to solve today in the dev method. We're going to get all these people in a car and we're going to send them on a happy long road trip, and we're going to use type erasers. Hello guys, welcome to the dev method, and today we're going to talk about type erasers, and let's just get right to it. So if you don't know what a type eraser is, I'm just going to give you a small example of maybe what that might be. There's actually quite a few of them already in the Swift standard library, and then also just like that you can use within the Swift programming language to get going. So I'm going to show you here just real quick one of them. And so we're going to call this our list. And there's this thing called an any sequence. Okay, and so we could pass in anything that is a sequence, and then that becomes our sequence. So in this case, the any sequence has got the elements of the string and put them into a list for us. And what that allows us to do is to do anything that we normally would do in some sort of for loop. So for example, for the character inside the list, we can print it out, right? So print out what that is. Let's run this, and we'll see that this happens multiple times. R-I-C-K-Y, right? That is the same thing as if we just took the original element here and then ran this. We'll get the same output. So it's kind of the idea. Now the thing is that we don't necessarily know what all these things inside the string are. So if that ever changes, that'll work. Let me just show you here. Let's just do another one with just some values. Let's run that on the list, right? Oh, there it is. Oh, just showing me the latest value. Well, anyways, it happened 5 times. I could see it down below. I know that's a little tiny, but it says 1, 2, 4, 5, 4, and then we have 1, 2, 4, 5, 4. So that's the idea of an any sequence. We don't necessarily know anything other than like it's integers that are in there, but we don't we have an array. We don't know that it's an array. So here I'll show the original. Okay, there we go. That's the original. So the original is an array of integer. So just to give you its type there, that's what it looks like. And now this one's going to be an any sequence of just the integer. But we don't know that it's an array. So that's kind of the idea of a type eraser. So we're going to walk through an example where we can make one ourselves. And then how do we make this thing? So the naming sequence, or the convention, I'm sorry, for naming the sequence that is a type eraser is any. So we'll put any in front of the thing that we're going to make. But the first part here is we have that problem. So we have a car, right? And then we need to add people to that car. So we'll do add, okay? And that's going to add something to like this array of something. I don't know why that keeps getting bigger. Let's run that, get that out of our way. Maybe it won't. All right, so we have a car. So I'll just say it's a car. There it is. And run it to that point. Yeah, so all we have is just the car. And then we can add things to it. So what do we want to add to it? So the first thing you might think is, well, we need people, or a person, or a human. So I'll make a struct called a human, yeah, and then give everybody a name, and then everybody a spirit animal. And what is that type of a spirit animal? Well, we'll just say it's a string for now. Now, here's the thing. If we wanted then to add things to the list, so we'll just say our passengers are here, and they are human. And they'll start off as empty, but then we'll add the human, like so. Now we have a car, add the human. Let's define some humans. So Ricky's a human, and his name is Ricky, and his spirit animal is, let's say, a lion, right? And then let's have another human. His name is Arik, and his spirit animal is, I don't know, a surfer. Okay, so you get the idea. So let's add Ricky, and then we add Arik. Now, it just so happens that the spirit animal, the value itself is not what we're necessarily worried about, because the value can change, but it's really this type here. So let's say like we have a couple different interests, and one of them is the spirit animal could just be animals. So let me just make a couple cases of an animal. So we have a lion, we have a tiger, and a bear. And it doesn't necessarily have to be just an enum, but that's the easiest way I can represent them right now. And all we need to know is that it's a lion. We don't need a string that says it's a lion. And then another one could be like sports. So we have a couple different sports. We have basketball, baseball, hockey, football, soccer. Okay, so we have a lot of different sports. So this makes it a little bit more difficult now, because how do we integrate these guys into the human? Because a spirit animal could be just like an animal itself, or it could be like this interest of sports. So it gets a little bit more tough to integrate these all together. So let me show you what we could do. So the first part you might think of, let's start at this point with the car. Well, the human here is always just a variable that is passed in, okay? But maybe that's not something we want, because we want to be able to do something like this. We want to say that this is a lion, okay? And this spirit animal is a tiger. And let's say there's another one, an Andrew, a human, a name. His name is Andrew, and he's a bear, okay? He's a bear. So the whole point of this is so that we can add these here, okay? But now we just kind of messed it up for any humans that like the sports. And we have a great way of doing humans for people who have a spirit animal of an animal, but not a spirit animal where it is some sport. So this is where we want to try and make it a little bit variable. You might think, oh, I can just put any here. And then this is an animal.lion, right? The problem there is that you have to cast, and that's not going to be good for what we want to do. So we got to keep it here in the struct of human. Now here's the thing. We also have this redundancy, and we're like declaring these variables that have the names, but what if we could create the struct itself, or some sort of object that's just called Ricky, and then reuse Ricky everywhere? So we could actually do that. So let's take the struct. Let's just remove the name for a moment. Okay, so take out this part, because that was redundant. All right, so now we just have humans with spirit animals. But we got to keep creating those humans to get those spirit animals. And right now it's a type of any, but we want a human that is interested in sports or interested in animals, right? So actually, let's change this spirit animal to interest. Okay, so there's similar interests here, and interest. There we go. So humans have an interest, and we're going to all put them in the car, but they all have to have like the same interest, right? So animals or sports. This is where this gets a little tricky because we can't really like, if you look at this type here, it's a passenger that is a human, and then each human has an interest that could be anything. It's a little too vague. And notice we have some compiler issues here too, so we have to define exactly what the type is. So let's just say for a moment, if we actually put animal in front of it, and then we got the car, and then I said, give me the passengers, and then I want all of their interests grouped together, so I use this map. So what would this be? So we run it all. Oh yeah, we got to add them. All right, so self.passengers.append the human. Okay. All right, so notice that auto completion there inside the map. See, the interest is any, but I want that interest to be like an animal because I need to know its exact type. What could I do? So I could say there's a nice little compact map thing that we can do. We could say as an animal. So that would work, but here's the issue. So now bring in another person. Let's say it's Brad. So Brad has an interest, but his interest is sports. He really loves basketball, right? It is possible now to not only add Andrew. Andrew is okay because he's an animal. I see it here. But now you could add Brad. But Brad is into sports. So when we finally pull out what the interest is in all these people, we find ourselves with, let me just print this out here so we can look at it below. We find ourselves with a car full of people who are interested in animals, tigers, and a bear, but then also ones that are interested in sports. So for the one passenger in the car, not very good car ride, or maybe rather boring, but maybe learning new things about animals, but not as interested in them. So how could we split this up? So let's backtrack a little bit. Let's take out these guys. Okay, let's keep the car there. We want to go through everybody's interest and we want to print that out. So we can still do that. Notice this is a type of any, so it's just an array of any items. So we want to change this into something a little bit more predictable. So let's take this human and push it into a protocol. Now we don't know what the interest will be until it's used later. So in this case, when Ricky is declared. So let's try this. We have to use what's called an associated type. We want to think of it as like a placeholder. I'll call it as an interest. Okay. Now its type isn't really any. It's just a thing. So let me fix some of these issues here with the protocol. So this is a read-only or a getter for the interest, and it's on the human, and we don't know what the interest is. It'll be defined later. And so we want a car, and we want to organize the cars, though, by interest, right? So here's the issue. Notice we get from the compiler a couple different errors, so let's read through them. First of all, without the add, let's comment that out, we still have an issue here. So human saying the protocol human can only be used as a generic constraint. Okay? So what we would do is maybe do something like this, right? A car of human. No, that doesn't work, right? But then it's saying it has an associated type requirement. So that has to be defined here. So maybe we do like a type alias of like animal. Well, not really. Like, see, watch this. So we could do where h.interest equals an animal. That could work. No, not quite. So there's a couple different ways to get around this. And what we want to do is really organize the cars by interest. And we can take in a human, but it's really this interest that we're interested in that we want. So we go passenger interest, okay? But we still have that problem of the associated type. So how do we fix that? Well, there's a couple ways to do it. What we need is a type eraser. So we need the human to go into here. And we want to know that it's a human. But we also want to know what the type of the interest is. So that's where we create any human. So how does the any human actually work? The any human is going to work by itself being a human. Let me get rid of some of this stuff down here real quick so we don't get distracted by those issues. So notice the struct here, any human, it says it does not conform to the type. So animal, right? Okay, well, let's just go with it for now. It's still really specific to animal. We got to fill in the rest of it too. So what is the getter for the animal? Let's just say it's a bear. So right now we have any human. It's not totally what we would want. We have this interest and it's always returning bear. We want that part to be variable. So what we're going to do is take the any human, put something that is defined as being a human that responds to the human protocol, initialize the any human with that, and then dynamically, as any human is being asked for what its interest is, it'll give back what that original value was. Okay? So we would do that with an initializer to give it a human. And this is where we run into a small little problem here too. So human also saying it's a protocol, has an associated type. What we need is a generic constraint, but this time we're actually going to do it right on the initializer. And I'm just going to say it's of type H. See that there? So now here's the thing. If we were to then put it in the interest here, you might think, oh, I'll just, whether it's private or public, I'll just have an internal human and do this and set my human to the passed in human, right? Well, not totally. It's still saying it's got the generic constraint. You might look at maybe one of the new features of Swift or the newer features of Swift and put a sum in front of there. Yeah, that's not going to work either. Still telling you you need some sort of like generic constraint on this. So with all that not working, here's what we got to do. So we put in the interest here. Yeah. And it returns the interest. Okay, take this away. Right? Now we're getting closer. Okay, we're getting closer. So we can't return just bear anymore. So what do we return? We return the human interest, which is an interest. Right? Well, we still can't declare human like this, right? And then also look at this here. Interest cannot be used as a value of on value of protocol human, of the protocol type human. Use a generic constraint instead. Yeah. So what we have to say is that the interest where the interest is equal to the human interest. It would be the same thing if we said I for this, or maybe T. Just put a T here, and then this is a T. So that would work. Now, I'm going to take that all back here. We also need to put the constraint actually down here. So it's not totally what we want up here. Let's take that. Okay. So where h dot interest equals T, like so. So this is a T, any human, T, okay? Now we still can't have this storage of just a human. So what we need to do is go through each one of these values that are in the protocol. So if we had like 10 of them lined up with even functions, we would have to then maintain and upgrade this any human with it, this type eraser. So what we need to do is actually set up like an underlying interest. So here's the interest, and what we're going to use is a closure. So this is one of the ways to do a type eraser. So we're going to say the closure returns a T, okay? And then instead of returning a human, we say return the interest. Just call it as a function. We're close, but now we need to say that our interest is equal to something that passes in the human interest. So that is the shorthand for the closure. Let me just show you here. The long version would be that this returns this here, like so, okay? Because this is a type of a function. This is the function or the block or the closure, and then it returns this here. See that? So it would be something like T, like that. Return it. So I'm going to skip all that stuff there, put in more of the shorthand. This is the shorthand of doing that return. So we actually have an any human right now, but it also has to guarantee that the associated types are all the same. Okay, so we don't necessarily know what that's going to look like with our car. So let's introduce the car again. So the car, we're going to still need that, this here, this passenger, right? But we still can't use the human. But what we can do is now use our any human, okay? And then what, though, is the T, that generic constraint for the human? Well, that will be our passenger interest, like so. So that solves just storing the passengers in this array. Next part, though, the human. Can't use it here, right? So we just do a generic constraint of H, where H has to be a human. We use H in here. We are so close. We're not all the way there. Notice it's going to say we have to pass it in as any human, okay? So I'll say that this is the eraser. So any human takes in the human, put in the human, like so. So what is this type? This is a human that has an interest. We don't have, though, the passenger interest, which is what we actually need. So put in the erasure, and then notice we will not be able to do that. Yeah, so the last part here is where the h.interest equals, so this is a generic constraint then on add, it has to equal the passenger interest. So that will actually get rid of our issue there. So let me actually put it on multiple lines. So we have the add, which takes in something that is a human, but then also an added constraint of that something that is a human, the interest of that has to also be equivalent to the generic constraint of the car. So next thing is, how does that actually play out when we declare a car? So we have the car, but we don't know necessarily what its passenger type is. So let's first create a car that is the athletic car, okay? And so that is going to be the car of sports, okay? Everybody in that car is going to talk about sports, so that works. Now, here's the thing. We still don't have any actual humans declared. We're not using any humans, so let's create a human. So remember Brad? Yeah, he's a human, and he likes sports. So his interest is a sport, okay? And his sport, again, is basketball. Okay, so that works. Just to show you with the type alias here, this is something that it'll ask you to add incrementally. You could have the type alias there, but Swift is smart enough to know that since this is the same property with that type, you don't need that type alias written out for you. So there it is, Brad. Let's pick out another person too. Let's say it's Sean. And let's say Sean has an interest that is also a sport, but his interest is hockey. So now we have Brad and Sean. They can go in the athletic car. See, we'll add a human, and we'll do Brad. Put in Brad there. So now notice Brad is like declared as itself. That is his value. It's no longer a variable that we're declaring. But Brad is defined, and we're using him. And now we'll add a Sean to the car. There we go. Now, if we were to put this into an array by interest, let's do this athletic car. Notice it's all sports. Okay. Now let's declare another human. And let's say it's Ricky. And his interest is actually animals. And what does he like? He likes the lion. Let's try and add Ricky to the athletic car. Let's see what happens. So add Ricky. Watch what it's going to say here. So the instance add requires that sports and animal be equivalent, which they are not. See here, this is its own type. This is its own type. They are not equivalent. So can't add him there. What do? Well, we make another car. Call this the animal car. Let's do a car with animal. There we go. Now we could add him to the animal car. So we have the two different types of cars. We have a car where the interest is animals, and then we have a car where the interest is sports. We can add them now to the cars, but they have to be separate cars. So we solved that problem with a type eraser of any human. So notice any human here doesn't hold a reference to the original human other than holding it through this closure. It actually captured the value of that human in the constructor and is using it here to always call what its interest is. So we use that closure here on the computed property for interest. So pretty cool. Now, if we wanted to add on to this later, like what else humans have? So humans have a name, right? So let's just say the name, we definitely know it's going to be a string. Okay? And it's a getter. So very similar as before, but now notice everywhere here, human has to be updated. So we have that protocol human defined, but now any human needs to be updated to understand what that name is. But what else do humans do? Let's say humans have a function of walk. And each human there walks and maybe returns an interest. So now that's guaranteeing that you walk and return your interest for that walk. So what we would have to do here on the any function, or I'm sorry, the any human, it's a walk that has to return t. Okay, so we have t here, and is that the one that we're going to return? I suppose so, but we don't necessarily want to make that assumption. So what we do is we get another like closure here, or another, in this case, we'll just call it our walk. And we know that is a thing that returns of type T as well. So we would do walk equals human and walk, like so. And then we return walk, call that function. So that's how that type eraser works then for either methods or functions that are on that. Let me get this out of here. There we go. But now that also means that everything that we declared before, Brad, Sean, Ricky, they all actually need to declare their own walk. Okay, so for a walk, when Brad's on a walk, he actually returns a different sport. He likes to return soccer when he does that. And for Sean, when he's on a walk, he returns then, he returns hockey again. So it doesn't have to be the same actual value, but it is just another thing of the type. Now Ricky, when he goes on a walk, he still has to return an animal, but he can return a different one. So his interest is lions, but when he's on the walk, he's going to give you a tiger. So that's the idea here. So if I have X and I'm all getting their interests, I can now go to every passenger and I can say for each passenger, I want them to walk, and then I want them to give me their interest, like so. Let me take this out of here. Go ahead and go. So I took the athletic car and I said, go for your walk. And the value history was soccer and then hockey. And then for the interest, value history here was first basketball and then hockey. And that makes sense because we added Brad first and then Sean first. The internal implementation of car is just appending them to the list, but it's using that type eraser here. So that's pretty cool. And it hides the implementation of like what was actually used. Was it Ricky that was used? Was it Sean? Was it Brad? Well, as long as they all agree on the same kind of interest, same type of interest, which is sport, we're able to show what they are here down below. So those are your type erasers. If you have any questions, you can leave them in the comments below. I'll do my best to answer the questions. If you'd like more examples, we can dive into more examples. I know this is a pretty contrived example, but there are other ways that you can use this in your programs when you're writing in Swift. So, thanks for watching. Have a good one.